Okay, hi. Let's do a short review on probability and let's solve some questions and do some examples. Okay, so we've got to remember probability is the study of how likely is an event to occur. So, for example, if I throw a standard dice of 6 faces, what are the chances of getting a 5? So there's 6 possible outputs in total, no? I can either get a 1, a 2, a 3, a 4, a 5, or a 6. So, total possible number of outcomes, 6. But how many of these outcomes match the conditions that I'm studying? Only this one, no? Because I'm studying when I'll get a 5. Therefore, there's only one option. So, the chances of me getting a 5 are 1 out of 6. Great. We can express probability as a fraction, or we can switch it to a percentage. If we want to get like an idea, we can multiply it by 100. And then we could see, oh, so there's a 16.6% chance that we get a 5. Okay, so what is the probability that I get 2 5s in a row? So I'm going to do 2 throws, and I want to get 2 5s in a row. That's the probability of events in chain. And what we do is we determine the probability of every event that needs to happen, and then we multiply all of them. So for the first event, I want a 5. So there's 1 in a 6 chance that I get a 5. And in the second event, I also want a 5. So there's also 1 in a 6 chances that I get a 5. Therefore, the probability would be 1 in 36. Another way of looking at this would be studying the total possible number of combinations that there exist. For example, on the first throw, I can either get a 1, a 2, a 3, a 4, a 5, and a 6. On the second throw, I can get a 1, a 2, a 3, a 4, a 5, and a 6. How many combinations exist? Well, let's see. I can either get a 1 and then a 1, a 1 and then a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. I could be counting like this. The fastest way to study the total possible number of combinations that exist is by, or at least the method I like to use is, I make some boxes, again, so there's going to be 2 throws. How many combinations exist for the first throw? 6. How many combinations exist for the second throw? 6. If I multiply them, I'll get 36. Okay, so there's 36 total possible number of outcomes. In how many of these outcomes do I get a 5 and a 5? There's only one time when this happens, only this combination. Therefore, the probability would be 1 out of 36. And we got the same result that we got before, right? So that's 2 ways of doing it. 2 ways of looking at it. Okay, so if I call this P5, right, the probability of getting a 5, that's 1 out of 36. If I can also study the opposite probability, or the negation, which is the opposite. So in this case, the opposite of getting a 5 and a 5 would be not getting a 5 and then a 5. So it's everything else. Therefore, the negation is going to be 35 out of 36, because it's all the other cases that are not covered here. Always, the probability of an event plus its negation, they add up to 1. If you're doing it in percentage, they add up to 100. I guess I'm going to do this example in a couple of ways as well. The probability that if I throw a dice 2 times, I get the same face repeated. So same number repeated. In this case, the total number of outcomes is 36. We already said that. And how many of these outcomes guarantee the condition? Well, we could either get a 1 and then a 1, or a 2 and then a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. So there's 6 outcomes when this is guaranteed. So the probability is gonna be 6 out of 36, which is 1/6, which again was like 16.6%. So I think there's a decent chance that we get the same face repeated twice. Another way of doing this would be by doing its negation. So what is the opposite of getting the same face repeated twice? The opposite is not getting the same number repeated twice. How would I calculate that? So I'm going to draw the two boxes. There's going to be two throws. For the first throw, I can get any number I want. I don't care. But for the second throw, I must get a number that's different to the last one, right? If I determine this probability, I'll get 6 times 5, which is 30, and 6 times 6, which is 36. Notice how these two, they're opposite, right? Because if you add them, they add up to 30 plus 6, 36. 36 divided by 36 is 1. So they are opposite. So by calculating its negation, you could now do 1 minus 30 by 36, and you would get the probability that you were looking for. Two ways of doing it. Sometimes when a probability is like too hard, looking at its negation is going to be a really useful trick to be able to determine it. Okay, so for this one, we're going to throw a dice 6 times. And we want to get a 5 again. We want to get at least 1 5. At least one. So now we could say, okay, the probability of getting a 5 in a throw is 1 out of 6. Which means in every 6 throws, I should get 1 5. Therefore, if I throw the dice 6 times, the probability is 100%, no? I should get it. It doesn't work like that. This shows a tendency, but it doesn't guarantee that the probability will be 100% in 6 throws. So that's incorrect. We cannot guarantee that. Maybe we don't get a 5. So how could we determine this probability? If we try to set it up like logically, it is going to be tough. So one of our strategies is determining its negation. So I'm going to call this P5, right? The probability of getting a 5 in at least 1 5 in 6 throws. So I'm going to take a look at its negation. What is the negation? The negation is not getting a 5 in any of the throws. And that's easier because I can set up the 6 boxes. And I'm going to make sure that I never get a 5. So let's determine that probability. So if I never get a 5, how many options do I have for the first throw? 5 out of 6, no? Because I only have 5 possible options. I cannot get a 5, so I can only pick 1, 2, 3, 4, and 6. 5. Okay, so for the second throw, again, because I need to make sure that I don't get the 5. And again, and again, and again. So it's this number times itself. 1, 2, 3, 4, 5, 6. Sorry, there are 6 throws. Miscounted. Okay, there we go. So it's going to be this number multiplied by itself 6 times, which is 5 out of 6 to the power of 6, which is more or less 0.3. I'm approximating this result. Okay, so that's the probability of not getting a 5. Therefore, the probability of getting a 5 will be the opposite. So 1 minus 0.3, we get 0.7. Alright, so that's the probability that we were looking for, 0.7. Alright, now I'm going to review some vocabulary that's covered in the lesson. So, again, I'm going to continue with the example of the dice. Let's call P3 the probability of getting a 3 when I throw a dice once. And let's call P5 the probability of getting a 5 when I throw a dice once. So P3 is 1/6 and P5 is 1/6, right? The opposite of P3 would be not getting a 3 when I throw a dice once, which is 5, 6. And the opposite of P5 will be as well 5, 6. Okay, now let's see what's probability of 3 U 5. Okay, so what does this symbol mean in mathematics? This U right here means union, and it could be translated for or, right? So what this means is the probability that I either get a 3 or a 5. Okay, so right now there are two possible outcomes. We can either get a 3 or a 5. So we have two options out of 6, no? If I simplify this, this would be 1/3. Alright, this is 3 or 5, or 3 union 5. They merge forces. And what is P3, 5? Like this. What does the symbol mean? This symbol in mathematics, especially group theory, which you'll study someday, means and. So we're determining the probability of getting a 3 and a 5. Of course, this cannot happen. We cannot get a 3 and a 5 at the same time with a standard dice in one throw. So the probability is going to be 0 out of 6, which is 0. No chance. Alright, let's do this exercise. We're going to be studying a couple of things, and after this, I'm going to vanish from the internet. Okay, so in a class of 20 students, 6 of them are blonde. Okay, 6 of them are blonde. And what else? 9 of them have an A in maths. Okay, perfect. Let's determine the following probabilities. First one, the probability that when a student is chosen at random is blonde. So let's see. Probability that it is blonde. There's 6 blonde students. 20 students in total. So this should be it. This can be simplified because 6 is 2 times 3. 20 is 10 times 2. So 3 out of 10. Alright. What is the probability that if a student is chosen at random has an A in maths? Alright, so probability that has an A should be, there's 9 of them, 20 in total. So that's it. Let's look at this probability. Probability of A or B. Or another way of reading it would be A union B. That's if a student is chosen at random. If it's blonde, it's okay. And if it has an A in maths, it's okay. Or both. We don't care. But if it follows one of those conditions, we're fine. That's what we're studying. So, I notice that this is complicated. Because I cannot just add the probabilities. And I can't multiply them because they're not events in chain. So since this is being complicated for me, I'm going to try to analyze its negation. So the probability that a student doesn't have an A in maths and is not blonde. How do we do that? Before we do that, I'm going to see who the negations of PB and PA are. So the negation of PB is 7 out of 10, right? Because 7 plus 3 is 10. And the negation of PA should be 11 divided by 20. Okay. I could also rewrite this as 14 over 20, yeah? Okay, so the probability that a student is not blonde and has not an A in maths is the probability that a student is not blonde. That's 14 over 20. And if I want another condition in chain, I need to multiply them. So times the probability that a student has not an A in maths, 0.385. Okay, so if we choose a student at random, this is the probability that the student is not blonde and has not an A in maths. So the opposite, which is what we were really looking for, the opposite is going to be 1 minus 0.385, which will be 0.615. Alright, and this is what we were looking for. Nice. Now, last thing we're going to determine is the probability of A and B. So the probability that a student is blonde and has an A in maths. So the probability that a student is blonde is 3 out of 10 times the probability that a student has an A in maths is 9 out of 20. If we multiply this, we'll get 227, 0.135. I guess it's not very likely that this will happen. Alright, so this is everything for this video. I hope this helps you with your homework. See ya. Bye bye. Say goodbye, Doraemon. It can't talk, it's a toy.